Yeah, another physics video. I don't know if I'm going to post this one, so we'll see what happens. Just a thought video. You know, what I'm thinking of and what I have to work on is just trying to find some sort of way to prove the distinction between this Einstein theory and, you know, partially my theory, but, you know, this sage thing, the idea of a mechanical process that accounts for gravity and time dilation. Which really isn't time dilation, but I'll explain that as briefly as possible. But it has the same effect in terms of the messing up of this idea of figuring out our essential velocity, absolute velocity, and whether that's relevant or not. So the key thing to know is that both theories are basically saying, you know, gravity is being caused by what's kind of referred to as a convergence, right? I mean, there's a flow of something that's pulling stuff in through gravity. So the one theory says the flow is being caused by you know, the shadowing effect between two objects. So this object gets shadowed from this pressure here. The pressure coming on this side of the bigger body would be shielded here, so there'd be a low pressure here and a high pressure here of some photon, some energy. And that's what's pushing it in, is that the low pressure created in the shadow is just forcing the two objects together. And Einstein's is this idea that the space around these things is warped, and that warping time dilation-y thing is creating a constriction in space. I'm not quite sure what word to use to describe it. So anyway, the point is they both have a similarity, and they both create a time problem. The time problem called, I would argue, for velocity is this argument that if you have a pattern, you know, that something's making, and then you have that thing move in a direction, that it has to make the pattern slower, because it's going to use some of its time to move this direction. So the time it takes to move this pattern slowly out, though that extra time is in this distance, so the pattern has to be made slower. So if you get accelerated, your metabolism slows down because your cells and the mechanics of your chemistry, the atoms, that all slows down because more of the processing is going into moving your body. It's having to expend time moving, so it can't spend that time doing what it was doing before. If it has to do some moving, it can't do what it was doing before. I guess that would be the argument. To simplify it, so both theories have this problem of creating a warp of time, a change in time. So it makes it difficult to say which one is right or wrong based on some sort of constant, you know, related to time. So anyway, that's not the real point I want to get to. So the real distinction is in the way we, you know, the semantics of the conversation. So when Einstein says the speed of light is the same in all references, or all velocities, he's not really saying that, you know, it's not really the constant, okay? He's saying that no, the speed of light isn't the same. I mean, it's same if from the perspective of the person moving, but from the perspective of other velocity frames, from other points of view, you've entirely changed the physics of the space. The space no longer has the same physics, and time is completely broken, and a photon is now moving like this. You know, everything's been slowed down in that reference entirely. So, you know, it's just, again, it's semantics, but theoretically the speed of light isn't the same because everything's been somehow slowed down. So the point is that we have these two things that are referencing each other. So let's just say there's two, I don't know, people? I don't know what, it doesn't really matter. Let me just try that. Alright, so this one's in the velocity. This guy's going fast, and this guy's going slow. and the timing is just right. They happen to be right across from each other right now. So this guy's going slow in, let's say, this direction, this guy's going fast in this direction, but they have this little moment where they're crossing each other's path, so to speak. So they have these two frames of reality, and in this guy's frame of reality, in a photon's moving really fast. I mean, in a sense that, so it's going to be tricky to draw, because what's basically happening is in what takes place, let's say, in 1 minute of this guy's time. So here's 1 minute of this guy's time, and I'll cut a little angle. So this is 1 minute of his time. 1 minute right there. In 1 minute of this guy's time, this guy is doing this much stuff. Okay, so like where this guy would just see in 1 minute, he throws a ball, the ball goes 4 steps and hits the wall. I mean, it just goes. It took 1 minute to do this. In his frame. This guy, from this guy's perspective, in 1 minute, this guy's ball just did that. It didn't go anywhere. So in this frame, the speed of light is much slower. I mean, a photon isn't produced as fast. Everything just happens, including photons, move slower in this slower frame. So, I mean, one thing that seems for certain is there'd be practically impossible for these two frames to communicate with each other, because this guy would be migrating through a time frame. You're expanding the permutations of time in a sense. Okay, this is like an expansion of time, and I mean, could theoretically this guy then also expand time, and you just expand time and expand time? You know what I mean? It's like cutting things into smaller pieces. I just don't know if that would make any sense. And I guess what I'm saying is I think there'll be a flaw in here somewhere. Somewhere this resolution won't have the resolution it's being argued to have. That it won't be able to slow down the creation of a photon. But clearly you can just see that if these photons are moving this slowly, so they're basically when the time this guy threw one, they're moving. So in a sense they are moving in this 1 minute's frame. They are doing this crookedy thing in his expanded, slowed down world. So yeah, the photon came out this way, but it's doing this curve thing until it gets to this guy's space, and all of a sudden it's going to go straight again. So that's the idea of it. Is that the whatever the border between these spaces would be, is where all of a sudden everything starts going curvy. In terms of even the production of photons. So the difference is that the speed of light isn't constant between these two places. The speed of light is very different between these two places. Even though from their references they're saying it's the same. From there, what they see is the same. Obviously the two things are not the same. And I just don't buy the argument that there won't be a flaw somewhere in this transition that can be detected between these two worlds. Certainly going from this fast world, so if he throws light into this 1 minute, and it goes into this guy's expanded world, then the light comes out, and it goes this slowly slows down thing again to this guy, in bendy space. So yeah, I just have to find the flaw. I mean, one of these two, I'm arguing one of these two worlds can't exist. I mean, you can't go too fast because you won't have enough time to do the things that need to get done. You won't have enough resolution of time, I suppose. Yeah, and it just creates this infinite regression problem, an infinite progression problem. I mean, how much can you parse, these things into tinier and tinier and tinier worlds, And if it's possible to bend space this dramatically, I mean time, with space, really, in the sense that the photons are not traveling. You know, you have to think about whether you want to say they're going more spaces or they're having to travel bigger spaces. So it's like the checkerboard goes from, you know, this size squares in our world, and then all of a sudden the checkerboard squares get really big, you know, in the velocity world. So as you go faster, the checkerboard squares get bigger and bigger and bigger and bigger. So you're ending up with this bigger checkerboard the faster you move. So the more velocity you get, the bigger the checkerboard gets. But then Einstein also says that somehow energy, as if energy wouldn't also expand. So if light, in my opinion, if Einstein's going to argue that light is expanding into this space, and that now photons are big giant photons that are moving really slowly through the big spaces, then why would he make the argument that you can't infinitely expand this dimension, this velocity dimension, and just keep going faster and faster and faster and faster? Because you have broken the speed of light. The speed of light doesn't mean anything anymore because this is being identified as the speed of light now. Okay, the speed of light has entirely changed once you're in this reference. Once you're in this velocity, let's say this velocity is 80% of the speed of light. Once you're in this velocity, Einstein's still saying the speed of light is 100% faster than that. I mean, it's still the speed of light from your perspective. Even though you're going 80% of the speed of light, you're still perceiving the speed of light as being 186,000 miles a second. So you're not seeing it as bigger. So why would he say there's some maximum number of how fast that you can't go the speed of light, when he's basically arguing that of course you can go the speed of light, because the speed of light will just, as you go faster, he's just going to say the speed of light goes faster. It'll always be 186,000 miles a second faster than you are. So no matter how fast you go, he's going to keep saying the speed of light is 186,000 miles a second faster than you. So he's just going to keep making this is an infinite potential to get bigger and bigger and bigger, and just keep going bigger and bigger and bigger and bigger and bigger and bigger forever. And likewise smaller, you could just go this other direction where you just get into this tinier and tinier and tinier checkerboard. Yeah, so that doesn't. So first, Einstein's argument against this creating this idea that somehow your mass will increase too much. Your mass can't possibly increase if the speed of light isn't increasing. If the amount of energy it takes to move light, the speed of light, doesn't change, if that stays 186,000 miles a second ahead of you, then everything else is going to be ahead of you too. You can't get any smaller than that photon unit. So how could there be some other unit that's now slowing you down or creating a limit, a speed limit? There is no speed limit. Alright, so that's a flaw in his own rhetoric, or his own terminology. If his math comes up with some reason why that is, there's a limit. I think it's going to be, as as Hofladay would say, an arbitrary limit. Because I don't think once you're allowing the speed of light to keep increasing, no matter how fast you're going, it's always going to be 186,000 miles a second faster than you. As long as you keep making the speed of light faster than you, there's no way you could be saying there's a stop sign somewhere. Yeah. Alright, so that's something to work with. That's some hope to find a flaw in these two systems. See, by my reckoning, what's happening, the time dilation again is happening because you're using up the photons to move in the direction. So that's why your metabolism is being slowed down. But quite obviously the limit, the brick wall, is there's going to be a point where so many of your photons are going in the direction that there's no time anymore to do the figure eight. So the figure eight has to turn into a straight line or a swirl, or it just won't be able to maintain the pattern that exists. The pattern will be too complicated for the amount of energy left over to do it. All the energy will be devoted to the movement, and there will be no energy left over to create any pattern. Yeah. So there's a definite speed limit, and velocity wouldn't be relative either. There certainly wouldn't be any of this, dilating of, your light is different than my light. Light is the constant in my description. The checkerboard is the same everywhere. The speed of light is the same everywhere, and the thing that changes is the metabolism of the stuff moving. Yeah. Alright. I just don't know if I can say anything more useful. So again, it's this whole clock problem. It's probably what we're looking for is redshift between, ideally, I guess the thing to do is to have two clocks in space far enough away from each other that you can eliminate the microsecond error kind of thing. You want enough distance between them where the clock doesn't have to be accurate to 0.00000 decimal points. You want to try to move that up as far as possible. But the idea would be just to try to shine a perfect bit of light at the other, from one location to another location, and see if you can create redshift. If redshift exists between those two locations. But again, see, there still end up being static locations. Yeah. Well, there's got to be a way to determine it. I would think there must be some. If you even shooting something off. I know they have a mirror on the moon. And if they bounce something off the moon while they're in two different positions, they should get a slightly different redshift between those two directions. There should be some way to determine absolute velocity based on redshift, if absolute velocity exists. Yeah. And what else? So how else can I find it from the time dilated point of view? Is that's the incidence of how often a photon is produced, but how the period would still be proportional to the slowed down time. Yeah, well, something I have to do too is go through the period. I have to figure out. I have to put everything in the common speed and time designation, so that I can make comparisons. What's the distance of the wavelength of light, let's say, of blue light and red light in Planck constants? What's the distance in Planck constants? I need the distance in some sort of more relevant to understand the difference between a photon being this big and the distance between them being this big is really relevant. Yeah. So that's something I got to think about. Obviously, because redshift would have to do with how much space you're actually cutting off. How much distance would tell you how much bigger these spaces are, and whether it's possible to have spaces so big that 1 minute of my time could have you know, an hour of somebody else's time or something. Yeah. Well, anyway, this is, you know, somebody moving's time with velocity. Yeah, so anyway, I just think this idea here, I think, just to say something, though, that, you know, by this definition, there would almost be an infinite velocity potential if the speed of light is always going to be 186 miles a second faster than you are, no matter how fast you're going. I think that's a paradox I've identified. So this video wasn't totally useless, because that's an obvious paradox. How can you have a speed limit when you have 186 miles a second opened up to you, even though you're going 80% the speed of light already? You have a huge, you can cut into that new 80. You can just keep going 80% of that new speed of light. And so that just keeps growing the amount of squares you can expand. I mean, it sort of begs the question that why is the universe running at this speed then? You know, when it could be doing 900 zillion times more stuff if it just sped up the engine by making the square smaller. You know, it just doesn't making this infinite is problematic. And I think the only way Einstein made it non-infinite is probably a contrivance. Yeah. It would have to be, like I said, if you're going to allow the speed of the speed of light to stay at 186 miles a second faster than you are moving. If the light's going to keep going away from you, no matter how fast you're going, it's going to keep going away from you at 186 miles a second. You keep expanding the universe. You keep expanding the time dimension. And you keep making it possible for you to make the squares bigger and bigger. Yeah, well, I've said it 4 times, so it's probably enough times to say it. So anyway, I guess you got to find the gimmick here. There's got to be an experiment that'll demonstrate one or the other. Okay, so I'll have to think on it. Yeah. I think I got a better way to say this paradox that's created with the speed of light that never goes down. It always stays 186,000 miles a second faster than you are going. So if you're saying you're going 80% of the speed of light, that your velocity is 80% of the speed of light, you can't be doing that if 100% of the speed of light is 186,000 miles a second faster than you're going. You see, you can't. How could it be possible for 100% of the speed of light to still be 186 miles a second if you're going already 80% of the speed of light? So you can never be going a percentage of the speed of light and then still have a 100% of the speed of light still available. It's not possible. That's it's one of those paradox things that just can't work. You can't be going 80% of something and then still have the potential to go 100% more of it. You should only have 20% more of it left. You can't have 100% more of available speed to go. And that's what it would mean if you still had 186,000 miles a second of available speed to still go. Yeah. So something has to break here. You can't use the term like you're going 80% the speed of light if in your time frame the speed of light is still 186,000 miles a second faster than you're going. So if the speed of light is still 186 miles a second faster than you're going, you can't possibly be going 80% of the speed of light. Yeah. So you have to use some other way to describe this. 80% of the speed of light in someone else's frame of reference. So you're going 80% of the speed of light in the other guy's frame of reference. I mean, you know, that's all this infinite regression thing again. So by this guy's standard, this guy's going 80% the speed of light. But from this guy's reference, he still has 186,000 miles a second of speed of light to play with. So he could go 80% of the speed of light. The new speed of light. Yeah, that's just not gonna, that can't work. So there's got to be a catch in that somewhere. You can't be going 80% of something in somebody else's frame of reference. Yeah. So that's no way at all. So as soon as you have any velocity, as soon as you're going 1% the speed of light, you're already out of a relevant frame of reference. There is no relevant frame of reference anymore. As soon as you have any velocity, you're in a perpetual chase. You're still at 0% of the speed of light, because the speed of light is still 100% the speed of light, which is 186,000 miles a second. So you're still going no percent of the speed of light. Yeah, so you have to come up with some other explanation for velocity than to compare it to light, because light's not the constant. Quite obviously. The speed of light just keeps expanding as you expand, as you move faster and faster, the speed of light just keeps going faster and faster. Yeah, that can't work. I mean, it's clearly a broken constant. And there's clearly no way, again, you could make this make any sense to say the speed of light constantly expands, yet the metabolism of atoms doesn't. Or there's some other, their mass doesn't change with it, or everything else doesn't change with. Of course, everything would have to change proportionally. I mean, if you're going to keep expanding the speed of light to be at 186 miles a second, you have to keep expanding everything else. There's no other part of physics you could possibly that isn't dependent on the speed of light as the standard. Energy included, everything. So how could you possibly say you don't have your mass gets too heavy or some other thing gets too heavy? Relative to the space, it certainly wouldn't be. It would only be getting too heavy relative to the other guy's frame of reference. And you're not in his frame of reference. So how the hell could you be getting too heavy in his frame of reference? You're going 80% of the speed of light in his frame of reference. Obviously your mass is only getting too heavy in his frame of reference. In your frame of reference, there's no problem at all, because the speed of light is still 186,000 miles a second. So how the fuck could your mass be a problem? Yeah. That doesn't work. That doesn't work unless you concede there is such a thing as a zero velocity. Has to be a zero. Yeah. Okay, anyway, till next time. I mean, you certainly have to end the regression into these expanding spaces, going faster, right? The moving faster people has to end. But you know, like I said, both ends have to. It doesn't make any sense. Yeah, so I just have to prove that it makes no sense. I mean, the idea that you have to go do away with this concept of an 80% the speed of light, because it's not what the thing is doing anymore. If it's still, the speed of light is still in its frame of reference 186,000 miles a second, it can't possibly be going 80% of the speed of light. Because the speed of light is still 100% of its original speed. Light is still going its original speed. You haven't caught up to it. So it's obviously you're not going any percentage of it. You're still sitting at zero. Yeah. Yeah, keep working on it. And I better finish this up, so I'll do some comments and, throw on the end of this video just to finish the video up. So this is an old Carla comment. I'm also merely contesting the interpretation of cause and effect. There's little black holes on the surface of the sun which are causing light bending. The math and everything else stays the same. There, I've revolutionized physics. Well, yeah, if you can point out how it does fit the math, then maybe you have. Or you can point out how they were formed, how it's consistent with how the rest of the universe works. I mean, look, this sage theory has been around a long time, okay? And it didn't exist for a long time for no reason. It existed for a long time because it does fit an awful lot. And it was only because of a couple of problems that I think I have resolved that it was discounted as not the correct way to view a thing. So I'm just saying, you want to do this, play this game, go ahead and play it, okay? But you haven't done anything. You haven't demonstrated that I'm wrong because you can make something up and set standards that I'm not. I'm obviously feeling the burden to go better than those standards, and I'm doing it by explaining. You're not going to explain where the black holes came from, are you? No. So, silly. Yeah, so just be an asshole, as usual. That's all you're capable of, being an asshole. So bravo, way to be consistent. LOL, this dude is dumb. It is meant as an intuitive thought experiment to give the layperson an idea about SR. I don't know what, special relativity. It's not an experiment he's about to publish in a peer-reviewed paper. The details don't matter, moron. Well, again, what's the point of it is the point, okay? It doesn't have anything to do with the real physics. The real physics are that photons don't do this suspended in space thing, and if you're going to say they do it because of this time warp, then you're going to have to explain how the speed of light basically is different in these different places, and blah 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 blah. It creates paradoxes that you're going to have to explain. You can't just say, no, I don't feel that burden. I'm saying it's not the straightest line to the solution. The straighter line to the solution is to say, yes, we know photons exist. We know photons are sometimes invisible. Photons are creating gravity. When you threw a ball in the air and the train doesn't go up straight in reference frame of the ground, straight to reference frame, okay, we've already done this ball crap. Again, my argument is a simple argument. Light doesn't have momentum in any direction, but 100% in the direction it's going. That's it. It moves no other direction. Modern cosmology, general relativity, quantum field theory are totally, essentially indistinguishable from magic. You don't like magic? Well, whatever. Blah, blah, blah. At least you got some counter-arguments to address, even if one to start with do understand the theories better. Blah, blah, blah. It's not. I'm just going to read the critiques. Last one for me, does I give up? Alright, we already did that, so we don't need to do that again. If photons have no mass, how they accumulate into particles that have mass? Again, I'm not the one arguing that photons have no mass. I'm saying their mass is completely directional, and that's sort of a thing to understand here, is that mass, energy, is directional. And that what makes matter matter is the fact that the mass, the direction of the energy, has been spread over the entire substance of the mass. It's been universalized. It's been I used a better word the other day, but it's this idea that the energy is spread out. It's unidirectional. Yeah, it's unidirectional energy, where light is completely one direction. So that's the difference. Mass is basically an accumulation of energy, which is an accumulation of mass. But yes, the mass is the energy. M equals E. Feynman and Einstein were wrong. Well, that's not very helpful. Some commenters below, no fields, no dicks, one field, there's a big fat expanding field, the speed of light equals the speed of time. Yeah, whatever. It's not terribly useful. Some lizard guy who I'm very untrusting of. There is no force, only structure. No such thing as fields. I totally agree. There's no such magical forces. It's all geometry and direction. No energy transfer, only the passing of geometrical information. Sort of, but I mean, yeah, okay. I mean, still you got to account for movement is movement. Forces are convenient for describing microscopic effects, but not the fundamental level. It is not what is really happening. Forces exactly are, we're being deluded. It's an optical illusion kind of thing. in the sense that it is so small and we're seeing an effect, we're not seeing the cause, and the cause is mechanical. So we agree at that anyway. This is great. I see what you're doing. Valuable. I said how much arguments. Let's see. They don't original thought. They're also refreshing to see someone blah blah blah. Planck scale upward instead of around. That's a lot of physics today. Blah blah blah. Let's do the replies. Let's see. 3 replies. Well, it's not going to show me all 3. So anyway, just do the odd dot guy. I'm a dot. Circles are indeed mechanical contrivances, approximations. If you prefer, you can expand trigonometric functions to an arbitrary degree of accuracy using Taylor expansion, so they can be expanded to give vanishing close to pi values. Real circles don't. Yeah, okay. Look, it's a checkerboard. You can't make a circle on a checkerboard unless you have a lot of squares, but you're still going to have the little square thing all around the edge. So, sorry I can't view your reply at this time, your other reply. There was some sort of crap, no doubt. Some more of this atom shit. He posted an awful lot of comments. Einstein wanted to call a theory invariance theory. Well, whatever. If he's too much of a... Look, he wasn't even famous then, so what pressure did he have? So he didn't publish it as an invariance theory. But whatever. This appearance of relativity time distinction, objects appearing distorted and reserved do not represent what is really going on in the grand scheme of things. Einstein lost the battle, though. Well, this is just silly. When Einstein published, there was no battle. He was not famous. He did not have to do any of that kind of crap, so I don't buy that argument at all. I don't know where you got that crap from. Hypercubes. Okay, well, this I'm not going to go for. I think your intuition, it's not an intuition, that space is cubic lattice of solids. Squares, cubes, hypercubes, I don't know. Hypercubes, fuck that. Fuck all that shit. It's much simpler than that. Let's see. Interesting that you testable prediction with atomic clocks. Yeah, well, it's not really testable in the sense we already know that atomic clocks don't work. Yeah, well, I mean, we already have demonstrated their fallibility by accelerating them and getting a different time. Obviously the clock is broken. I mean, obviously when they accelerate the clock, they're not going to space-time. They're broke the clock. So, yeah, obviously. Having scruffy hair does not make you Einstein or a genius, by the way. Nice hair. So, the space child, you're just too fucking irrelevant, so I'll say goodbye to you. Let's see. Thanks for the video. You're very, very interesting. Subscribe to you. Okay, who cares? Nice, thank you. Very evil petting zoo. He's always an idiot, so we ought to be there. And there's just no reason, in my opinion, for them to go there. Yeah, so this is where I was making a simple comment, that there's no point in talking about what happens at mega velocities when you can't create matter going mega velocities. So, again, it's all theoretical, and it's a space you can't know. You can't, I mean, it's awful presumptuous of these people to say, let's say, I'm saying that matter is made out of energy, that there is no other mechanical part, there's just the energy and arrangements, and the arrangements are based on a geometry that's possible for the connection of these little dominoes. So it's a very simple mechanism. This other people are assuming that matter is some sort of other thing. It is actually like batteries, like it is actually a machine that is collecting energy and then spitting it back out again, and that the matter has some kind of body. Well, if the matter has a body, how do you know it can travel any velocity without the body being broken down? So anyway, you say plants and animals exist, the earth exists. I say they don't. There's no reason to go there. What is your hypothesis that I'm not a billionaire, not immortal, not a godlike or awesome powers? You are wrong. Whatever you're saying is just crap. I'm just saying you don't start theorizing about things you don't have information about. We have no information about velocities that are 8% of the speed of light. So I'm just saying I don't know why somebody would be presumptuous about what's possible in those environments. You don't need to do that to explain gravity. If it weren't for their fatal flaws, Lesage-type models would presumably yield the inverse square law, but unfortunately their proponents, not all gravitational phenomena can be accounted for by such a law. Well, you say so. Okay, so again, it's not a law, it's just a principle. But you just say that, right? You're saying it can't account for it. I'm saying it can account for it, and I don't see any other objections except for the heat argument and Feynman's argument. I've disposed of both of those arguments, so what other argument do you have? Newton's theory is only an approximation, a pretty goddamn good approximation, and the fact that there are subtle distinctions that take place. Okay, I mean, obviously, look, we can say even just shadows, right? If I create a shadow, there's this effect where the shadow dissipates with distance. So obviously there's some problem, you know, in the sense that light does bend. Okay, so we can go back to Newton's rings, and then they have this thing called Einstein rings now. Now, are we going to see the logical connection between Newton rings and Einstein rings? So surely gravity is a little more complicated in the sense of the fringes. Okay, so the fringes create a dampening effect with distance, where the shadow gets less and less strong the further away something gets. It gets diluted. So yeah, you have to put that into the equation somewhere. So yeah, so yes, Newton is a little bit too fine, okay, because it's basically making some rules that say the shadow has a clean line. There's certain, you know, it's making some hard lines where the line is a little bit soft, and it's a little bit broken because of other phenomenon. But there's an awful lot of phenomenon to consider, right? You got the rotation of the sun, you got the heat of the sun, you got a lot of different things that are also fighting the gravity or distorting it. So yeah, it's a little more complicated, but obviously the Newton, as a model, it's perfectly valid, and that's really the description here. We're comparing two completely different models. One that's saying time and space is being distorted to create a convergence, and another model that's just saying photons are creating pressure that's creating a convergence. And I'm saying the pressure model wins the Occam razor argument. General relativity is as solidly established as any theory in science. No, gravity is established as any theory in science, okay? And general relativity is a description of gravity. And there's nothing wrong with the general description of gravity in general relativity. The problem with general relativity is the presumption that light, even when you're going 80% the speed of light, is still going 186,000 miles a second. That's a problem. Faster than you're going. So you already have a velocity of 100,000 miles a second, plus you've now just added this extra 186,000 miles a second to the equation. That's a problem. So I'm sorry that theory hasn't been explained. Most of the uniquely relativist effects that it predicts. So again, it didn't predict things; it explained things. The lensing effect was already talked about 10 years before Einstein published, and certainly the problems in Mercury's orbit were talked about long before Einstein published. So the idea that Einstein published a predictive document rather than an explanatory document might be, I think it's a fair argument to make that Einstein constructed his theory to conform to the facts, not so much that he constructed it predicting facts. Some of his predictions have been collaborated to much higher levels of precision. For example, 2005 experiment of sun's deflection of radio waves. It confirmed GR's prediction with a precision of 1 part per... Yeah, it doesn't... Obviously, again, just give Newton that shadowing effect. So give it an equation to create a dampening of gravity by distance. Okay, the shadow is sharpest. If I put something right in front of my face, the shadow on my face is going to be very harsh. If I put something right in front of the camera, the effect on the camera of the shadowing effect, of the blocking effect, is going to be very harsh. If I put something in the middle, that's where it all gets kind of fuzzy. So yeah, that's an effect. That's a reality in the world. It's something Newton discovered, and it's something obviously Einstein incorporated into his mathematics. So I'm just saying that doesn't disprove other explanations for the effect. I mean, again, you're not meeting your burden to say why it makes more sense to bend space than it does to merely have photons that create pressure. The pressure argument is more consistent with every other observation of the universe and how it's working. The bent space thing doesn't. Let's see, he's not disagreeing with observations and calculations, only interpretations. Well, not exactly, but yes. To a part, yes. I'm obviously not denying the existence of the moon. I'm not denying the existence of something that's been established. What I'm denying is that the gravitational lensing is being caused by curvature in space, and not something like the fact that when you get higher gravity you have a higher density of particles for which light will be refracted when passing through them. Yeah, there's other explanations for lensing besides bent space. Okay, so moving on. Yeah, still got some time. Let's see, so we got 2 replies here. Well, looks like there's only 2. Alright, so this is the I am my dot guy again, so he's throwing some kind of light does not light does have a momentum, although it is in the not in the classical sense. So he's saying light does have momentum. So that's what Einstein did here. Well, I don't know if Einstein did it. But the point is they changed momentum, I guess, is P. So they recognize the fact that photons are carrying energy, and that carrying energy means you must have momentum. So it's just a concession to that reality, which makes it possible now to bend photons, because now they have some form of substance, or gravitational, a mass substance, some relevant mass to the equation. So now you can put them in the equation and have them affected by strong gravity, even though they're a very small mass, an infinitesimal mass by comparison. But at least now they can be formulaically relevant, where if you gave them 0 mass, you couldn't make a photon move. You know, from gravitational lensing, you couldn't do it if you don't give the photon some mass. Not discarded completely, though. I would say logical systems are still described quite well by F equals ma. Well, force equals mass times acceleration is still playing a funny game with this word, what a force is. So I'm not too thrilled with the word force. You know, obviously, how much velocity you're going to have to meet velocity with to overcome a velocity seems obvious. So, I mean, force has to always be turned into some other thing's velocity. You can't have a force unless you're moving something at something. So again, that's the trick of this. It is just the higher speeds of longer distances. M equals mc squared does it so much better, not to mention the civil and mechanical engineers use the classical equations to design everything they do. Well, you know, they're even using, you know, civil and mechanical engineers, I would argue, are doing things even more simply. They're not even bothering with E equals mc squared. They're not bothering with any of this theoretical physics. They're just doing the side angle side stuff. They're doing the basic heat equations. They're basically doing the thermodynamic equations, stress equations, all those equations. You don't need any of this theoretical bullshit to do any of that. Superseded, I should say. Classical momentum and electromagnetism are still immensely useful. They are also used in a lot of physics research in systems relatively large and involve sea motion. Yeah, well, obviously classical mechanics, I think, are still relevant. And I think the only problem with classical mechanics is the addition of understanding these subtle mechanisms. The subtle mechanism first, that we know the speed of light now, so we know that, you know, light traveling long distances is old light from things that aren't where they are now. We're seeing something as it was, not as it is. So that's knowledge. And then also the knowledge we gain from recognizing that we can see phenomenon, like the blurring of a shadow, that demonstrate that there's something in the field, something in the mechanism that lacks a purity. It doesn't fit a straight line mathematics. There's obviously some other influence that's breaking the straight line, you know, that's fuzzing boundaries, and that we can understand those other influences. So anyway, there might be some new comments. This is a couple of days old, but I have to sign into the channel to see what the comments are, and I haven't done that. So I'll do that some other time. So it is sort of irritating. The comments really aren't published in order of when they were published. So you have to go through the whole list sometimes to find new comments that were posted to old videos, which is sort of a hassle. Yeah, sort of is. You know, I don't really want to go back through 24 videos. But anyway, Yeah, so that's enough for now, I think. So again, I'm still going to think on this idea of how can you possibly be going 80% the speed of light, and then the speed of light still has 100% potential to go faster than that. You know, you can't be going 80% of the speed of light and say the speed of light is still 186,000 miles a second faster than you. How can the speed of light be faster? How can the speed of light be 100% the speed of light faster than you're going? If you're going 80% the speed of light, it's not possible. You can't be going 80% of something and it can still be going 100% faster than you. Yeah, that just doesn't. 80 and 100 doesn't work. yeah. You can't make that add up to 100. So there's a problem, and I have to work out that how I can prove that problem is catastrophic, and then I win, and I can get physics back to being rational. Yeah. Anyway, so until next time. I think that's all for now. So always stuff rolling. You know, I really got to write down more notes. I got to start writing more stuff. These little things occur to you as you start thinking about this stuff. Anyway, till next time.